I want to talk about matrices and how we can use C++ to process or do some matrix operations. And basically, what a matrix is just um, set of numbers with certain arrangement. Okay, and here's an example of that. You have it's a rectangular grid. A matrix is a rectangular grid with rows and columns associated with it. So here's an example of what a matrix would look like, right? So it's a bunch of numbers in two dimensions, in basically two dimensions, a grid. So you see how that can translate directly into C++ is we have two-dimensional arrays, right? So you could store this grid in a two-dimensional array and then perform some operations on it, okay? Well, matrices are covered in linear algebra, so um, that's not a prereq for this class, but we should be able to perform some basic operations, and they're actually very good to use these for examples to see how to use 2D arrays in C++ or other language. Okay, where do we see these as being useful? For engineering, um, one of the most common uses is to just solve a system of linear equations. Okay, so like in this case, here's a quick example of that, right? So you want to solve for x and y in this case, right? So you have two equations, two unknowns, and you can use substitution or simultaneous equations to solve these, right? Well, using linear algebra, with the matrices, you can actually use matrices with different ways to go and solve and do the same thing. Okay. In order to do that, um, and you can go through and solve, see what x and y is, right? Pretty easy here. Uh, but it could be there's many more variables in this, right? Which would make it a bit more complicated. But matrices allow us to do that, to solve equations like this with many variables. In order to do that, there's certain operations that you have to be able to perform with matrices, okay? And there's things you could perform, and maybe you could do addition, subtraction, transpose, multiplication, division. Um, uh, there's a lot of things that can be performed, right? And I'm going to take a look at just two. I'll do a couple of examples. I'm going to do an addition. So, like if you had two matrices, let's say this is a matrix and this is a matrix, and you wanted to add them together, what would you do? Well, it would be this first, the left hand or the row, row one, column one, or in C++ terms, we would say this is row 0, column 0, row 0, column 0. And you're adding just those two together, right? And then you come up with a result, another matrix, which just has this and this added together, right? And then this added to this and stored here, okay? Same thing here. So this would be like in C++ terms, this would be like row 1, column 0 plus row 1, column 0. And then that gives you this term. And then the next one is, row 1, column 1, row 1, column 1 for the second matrix, because this is a matrix, and this is the resulting matrix. So then you would have, 7 plus 2 for this and this one. Okay, so relatively easy to see that, but I want to go through and write the code for this, and you can see that. All right. And the next thing is transpose. Transpose is another common matrix operation that's performed. Okay. And here's an example of it. All you're doing is you're going to just take the row, so that our column. See, here's a column 1, and I'm going to make that our column 0 in our terms, right, in C++. And here's column column 0 now becomes row 0, right? And this column becomes row 1, and the third column or column 2 becomes row 2. Okay, so we're just switching those. So those are the two examples I'm going to look at. This is in section 8.4 in the text, and it would be good to read through it and get a general idea of it. There's one other operation that they perform. It's called a determinant, and they talk about a little bit. That's a little bit more involved in the code, so I decided not to do an example of that. But those are all things that when you take linear algebra, you'll see. Okay, so I'll work through these couple of examples. All right. So that concludes essentially 2D arrays, or at least what I'm going to cover. And just what it is. Basically, it's a block of data, right, stored. And the way we access it and work with it, we set it up as a grid, right, a two-dimensional grid. And what you'll see, like what we previously took a look at, matrices, is it works out really well for that, right? Okay. And just in general, arrays are good, right? We usually a lot of times what we'll do is take something from a file, read it in, process it, and then maybe write it out back out to a file. But they're useful for storing data and then in memory, and then we can go and process it and perform different operations. Okay. And just uh, so a lot of times when we're dealing 2D arrays, right, best way to visualize a set of data is a table or grid, right? So it's not too hard to visualize that. One thing I will say is that it's you can go beyond 2 dimensions. You can have a three-dimensional array. Three-dimensional array, you could view that like a cube. You could think about that as like a cube. Beyond 3 dimensions, you can have beyond 3 dimensions, although it gets to be a bit more complicated, but maybe harder to visualize. You can see it. Think maybe if it's 4 dimensions, maybe that's an array of cubes, right? So you could keep going. You could keep going beyond that. You could have maybe I think it's 256 dimensions, which is kind of crazy, but you can have that. So you could actually go beyond it. So that's essentially it. Those are some really key parts of working with 2D arrays, and there's some good examples where it works out really well. And that's it.